Alright, this lesson deals with what's called the multiplicative property of inequality. And we'll see what this is in a little bit. Let's take a look at this example, this inequality. And when we talk about an inequality, what we're talking about is that we don't have an equal sign. We have a greater than, a less than, or equal, or a greater than or equal. So it's involving the less than and the greater thans is what we're talking about with an inequality. Now, the example that I have in the green, which is x minus 3 is greater than 4. Now, if we solve this, we solve it just like we would in equality, or in other words, if we have an equal sign. So in other words, they're subtracting 3, we would add 3 to both sides, and the 3's cancel, and we get x is greater than, the sign stays the same here, 7. So what this is saying is that any number greater than 7 would make that original inequality true. So I should be able to put a number greater than 7 in for x right here, and it should make this true. So let's try one. A number greater than 7, let's try 8. So if I put 8 in for x, let's see, 8 minus 3 should be greater than 4. 8 minus 3 is 5, and 5 is greater than 4. So, and if I kept on checking these, any number that I put in that's greater than 7 would make this inequality true. Now let's take a look at the example that I have down below, which is in the brown there. And in this example, I have a negative x plus 2 is less than 3. Now if we go through this and we solve it, let's see, they're adding 2, so we would subtract 2. And the 2's cancel out. So I have a negative x then is less than, let's see, 3 minus 2 is 1. Now, we still haven't quite gotten x by itself. We have a negative x by itself. And remember, there's really a 1 right there. So they're multiplying by a negative 1. We're going to divide both sides by a negative 1. And what I would get then is, let's see, x is less than, okay, what's 1 divided by a negative 1? A negative 1. Now, this is saying that any number less than a negative 1 should make the original inequality true. Remember, my original inequality was a negative x plus 2 is less than 3. So let's try a number. Let's pick a number less than a negative 1. Let's try a negative 2. So if I put a negative 2 in for x, so I'm going to take the opposite of whatever x is. We're saying it's a negative 2. Plus 2 is less than 3. Let's see. The opposite of a negative 2 is 2. Now, is 2 plus 2 less than 3? And you can see we've got a problem, because we said any number less than a negative 1 should work. And what's happening here is really what this lesson is about. And this is something that you really want to make a close note of in your notes, is that when you have an inequality like I had, and I'm going to erase this stuff right here, whenever you have an inequality like I had over here, so if I have a negative x less than 1, whenever you multiply or divide both sides by a negative number, that's something that there's something special that has to happen with the inequality. So again, let me say it again. Whenever you multiply or divide both sides by a negative number, like we did here, we have to switch the sign. So if I'm going to divide both sides by a negative 1, I've got to switch the sign. So x then is greater than a negative 1. So that is my solution. Any number bigger than a negative 1 should work. Let's try it. Let's try a number. A 0 is bigger than negative 1. Let's try that. So if I had, my original was a negative x plus 2 less than 3. Now if I put 0 in for that, let's see, the opposite of 0 is 0. 0 plus 2 is 2, and 2 is less than 3. And you can see that that works. So the rule on this is that whenever you multiply or divide both sides of an inequality by a negative number, we got to switch the sign. So let's keep that in mind as we do these examples. All right, in example 1, it says graph the solution of the opposite of x is greater than or equal to 2. All right, so what we need to do here is I've got this inequality of a negative x is greater than or equal to 2. I want to solve this. Now remember, there's a 1 there. So they're multiplying by a negative 1. We're going to divide by a negative 1. But I'm dividing both sides of this inequality by a negative number, so I got to remember to switch the sign. So these cancel out, so x then is less than or equal to, let's see, 2 divided by a negative 1 is a negative 2. So my solution then is numbers less than or equal to a negative 2. Now, we need to graph that then using real numbers. Now remember, real numbers is a solid line, integers would be dots. So let's show numbers less than or equal to a negative 2. So I'll put a negative 2, negative 3, negative 4, negative 5, and so on. So a closed circle on a negative 2, and everything less than or to the left of that would be the solution of this. All right, in example 2, same thing, graph the solution. Now I have 4 minus x is less than or equal to 6. All right, first thing I'm going to do here is get rid of the 4. What could you add or subtract a 4 to cancel it? Well, I'll subtract 4. And remember, we don't do anything with the inequality if we're just subtracting a number. It's only when you multiply or divide both sides by a negative number that we got to do something. So now I have a minus x left is less than or equal to 2. Now remember my 1 in front there. Alright, so let's see, they're multiplying by a negative 1. I have to divide by a negative 1. But since I'm dividing both sides by a negative number, I got to switch the sign. Like that. And 2 divided by a negative 1 is a negative 2. Now, using integers or dots, I want to show on a number line numbers greater than or equal to a negative 2. So here's a negative 2, negative 1, 0, 1, 2, and 3. Alright, so numbers greater than or equal to a negative 2 using integers or dots. Well, a negative 2 is greater than or equal to a negative 2. A negative 1 would be, 0 would be, and so on. So all these numbers here, and then I'm going to just darken that arrow to show that they keep on going to the right. Now, something I need to do is I need to add a negative 1 over here just to emphasize that negative 1's not part of it, okay? And I want to show that, you know, on my graph to show that negative 1 would not be part of the solution. All right, one more example. Graph the solution of a negative 3x plus 4 is less than or equal to 13, and graph it using real numbers. All right, first thing I'm going to do is subtract 4 from both sides. So I have a negative 3x is less than or equal to 9. Let's see, they're multiplying by a negative 3. I'm going to divide by the negative 3 or a negative number, so I got to switch the sign. Now my solution then are numbers greater than or equal to a negative 3. Alright, so I'm going to show a negative 3 here, and then I'm going to put another number to the left of it, just as a reference. Then we have a negative 2, negative 1, 0, 1, and 2, and that'll be good. Okay, show numbers using real numbers greater than or equal to a negative 3. Greater than or equal. There's a line under there, so I have to have a closed circle on that. And then everything to the right. And it's a solid line because we're talking about real numbers. Alright? So again, really what this the main theme of this lesson is whenever you multiply or divide both sides of an inequality by a negative number, we got to switch the sign.